It's another day, and we want to look at integration using trigonometric substitution method. And we have an integral there that well fits the method that we want to apply. So we want to look at how to go about solving this integral using the substitution, trigonometric substitution. And I'm going to introduce in the variables that help me deal with this part. The first knowledge before even we go to introducing this is I want us to keep in mind this identity that sine squared x plus cos squared x is equals to 1. Or in other terms, if we want to put it in a more better way, cos squared x is equals 1 minus sine squared x. So in a nutshell, because this is a square root, I want inside this square root to be left with 1 minus sine squared x. Because I know that 1 minus sine squared x will give me cos squared x. So I need to deal with 3 and 5 in such a way that they will not affect my solution. Or I could even factor them out, literally. So what I could do is I could think of a way of rewriting the same equation such that I'll take out the 3 and 5. And one way of doing that is by being a little bit clever in the way I select my x. So my x will be the square root of 3 all over the square root of 5 sine theta. I cannot say sine x because I'm saying let x be equals to that. So you see here what happens? It will be, if I square this, x squared will be equals 3 over 5 sine squared theta. And you can see what will happen. The 5 and the 5 will cancel. Then the 3 and 3 I will be able to factor out. But I'll come back to that in a moment. So I let x be equals to, then this is where the trick is. And that is where the challenge could be, the selection of this part. I have to be a bit keen with it so that I'll be able to solve out my equation easily. So a number of things I know about this. I need to change from the x to d theta. So now I find out what is dx d theta. It will still be square root of 3 over square root of 5. The d theta definitely changes. What do I get? I'll get cos theta. So now I have my x squared, and also I have my dx. But now I need to take the dx, the subject of the formula. So dx will be equals to the root of 3, the root of 5, cos theta, d theta. So I have the two parts. I have my dx and I have my x. So those are the two I want to take now into the equation. So let's get back to our original equation and see what that means when we are doing the integral. So our integral is dx over 3 minus 5x squared. Let's put them back. I'll start with dx. It's root 3 over root 5 cos theta d theta. Now let's come down here. It will be the square root of 3 minus 5. You remember x squared, it was 3 over 5 cos, sorry, not cos, but sine squared. Now you understand why I took the square root over 3 over square root of 5 as then sine theta as my x, so that when I square, it becomes 3 over 5. Now you can see the 5 and the 5 cancels. These 3 and that 3 are common to each other. So I'll be able to take it out. I'll be left with 1 minus sine squared theta. Let's take the next step slowly. That will be together in that. So it will be square root over 3 of square root of 5, the integral of cos theta. Here, it is a square root of 3, 1 minus sine squared theta. Obviously, we are integrating with the theta. And 1 minus sine squared theta is cos squared theta. And it is a square root. So we have the square root of 3, and then the square root of 1 minus sine squared theta. So 1 minus sine squared theta is cos squared theta. So that's what I want us to remember. 1 minus sine squared theta is equals to cos squared theta. And so the square root of cos squared theta is equals to cos theta. So there, this is now what happens based on that knowledge there. So this becomes square root of 3, square root of 5, cos theta, d theta, all over root 3, cos theta there. And therefore the cos theta and the cos theta will cancel out. I'm sure this will be root 3 over root 5 divide root 3. And when you introduce multiplication, then automatically that will cancel out. So that becomes clear for us now when we do that math. And therefore, this gives me 1 over square root of 5 integral of d theta, which is 1 over square root of 5 theta plus c. That is our solution, but I would not leave the answer to that point. Why? Remember, our original equation was in terms of x. So I need to write back, introduce my x, so that I can write the answer as x. We had said at the beginning that x is equals to root 3 over root 5 sine theta. Therefore, sine theta is 5 over 3 to power a half times x, which is true. And so I want to make the subject of the formula. Theta will be the sine inverse of 5 over 3 square root of x. And then I can substitute that into the equation, and therefore I can comfortably say that the solution for my equation is dx over 3 minus 5x squared should be equals to 1 over root 5 sine inverse of square root of 5 over 3x plus c. I hope you've been able to follow through the steps. You can review the video again. And again, if you like the videos that have been, kindly subscribe. And I want to thank you so much for your time.